I'm going to go through all trigonometry in this video. First we have triangles, which is the main shape of trigonometry. There are 3 types. Scalene, which has all sides uneven. Isosceles, which has 2 even sides. And of course the equilateral, which has all sides even. And of course each triangle has a property, so I'm going to go through these now. The scalene property is that all the angles are different. The isosceles property is that 2 of its angles are the same. We call these type of angles correspondent angles. And of course the equilateral triangle has all the angles correspondent. This is because all the angles in each triangle add up to 180 degrees. Hence, each angle in the equilateral triangle is 60 degrees. The area of each triangle is base times height divided by 2. We can see that this is the base, and this will be the height. So we can see the blue shaded area is the same area as this triangle area. Now that we've covered the basic concept of triangles, we can cover all the different types of angles. There are 5 of them. First is a 0-degree angle, and as you'd guess, it's 0 degrees. An acute angle is an angle that's more than 0 degrees, but less than 90 degrees. A square angle is always 90 degrees, and is usually marked by this red square. The obtuse angle, which is more than 90 degrees, but less than 180 degrees. And last but not least, the reflex angle, which is more than 180 degrees, but less than 360 degrees. Next, we're going to do an exercise to test your knowledge on trigonometry. The exercise states there's a triangle with 70 degrees and 60 degrees, an unknown angle, and we need to find this unknown obtuse angle. So we know 70 degrees plus 60 degrees plus this unknown angle x is equal to 180 degrees. This 70 degrees plus 60 degrees turns into 130 degrees. Next, you can minus 130 degrees off both sides to get x is equal to 50 degrees. So we have 50 degrees. And then we have 50 degrees plus this unknown angle is equal to 180. So this will be equal to 130 degrees. Next is trigonometric functions, which is arguably the hardest part about trigonometry. There are 3 main functions: cosine, sine, and tan. There are 2 ways of visualizing how to use these functions. One is a basic triangle, such as a right triangle, and the other is a unit circle. First, let's try to visualize it with a triangle. We can use this using these trigonometric ratios. Now there are 3 sides of a triangle: the adjacent side, which is right next to the hypotenuse, and the angle, the opposite side, which is the opposite side of the angle, and the hypotenuse, which is always the longest side of the triangle and is a squared plus b squared equals c squared. Due to this formula, c is square root of a squared plus b squared. Anyway, moving on to the ratios. Cosine is equal to a divided by c, so adjacent divided by hypotenuse. Sine will be equal to b divided by c, and tan will be equal to b divided by a. For example, we have a triangle with 30 degrees and a side of 5, this is the opposite side, and then the hypotenuse we need to find. So we know that we can use sine, so sine of 30 degrees is equal to 5 divided by a question mark. So we can swap these around to get the question mark will be equal to 5 divided by sine 30 degrees. If you plug this into a calculator, you get that our unknown value is actually equal to 10. Hopefully you've been taking some notes so far. Next is going to be about the unit circle. Now the properties of the unit circle is that this x value is cosine and this y value is sine. We also start using things like radians, which is pi divided by 3. And this is just equal to cosine of 60 degrees. Anyway, knowing the reason why radians are radians is kind of useless. All you need to do is just know that pi is equal to 180 degrees. The radius of a unit circle is always equal to 1. This is because sine and cosine can never exceed the value 1 and negative 1. For example, cosine can't be 2 or negative 2. New formula unlocked. The formula is one of the trigonometric identities. Sine squared theta plus cosine squared theta is equal to 1. Why is this true? Just imagine we took this triangle out of the unit circle. We have the x value of cosine, the y value of sine, and the hypotenuse of 1. Remember the formula, a squared plus b squared equals c squared? Well, we have cosine of theta squared plus sine of theta squared is equal to 1. When you write sine squared of theta, you always write the square before the theta. That's just how you write it. Oh nice, we've moved on to inverse trigonometric functions. These are actually pretty simple. For example, tan of x is equal to y. Well, then we have the inverse, which we write like this, of y is equal to x. So we flip the x and y around to get different outputs. These functions are very useful for finding angles. Here's another example of how to use inverse trig functions. We have the hypotenuse of 30 and the opposite side of 15. We can find the angle by writing sine of this unknown theta is equal to 15 divided by 30. So we can swap these around to get arc sine, or the inverse of sine, will be 15 over 30, which we can simplify as 1 over 2 is equal to theta. And of course, calculators are required. We actually have 3 more trig functions to cover. This will not take too long. Secant, cosecant, cotangent. These are just the reciprocals of cosine, sine, and tan. For example, cosecant is equal to 1 divided by sine. As for cotangent is the reciprocal of tangent, and secant is the reciprocal of cosine. Now the last thing to learn are some theorems. One of these trigonometric theorems is Thales' theorem. This states that when you have a triangle with a 90-degree angle and all the corners are touching the sides of the circle, it will always pass through the middle of the circle. Now Thales' theorem is true due to the arc theorem, which states when you have an angle of A on the very edge of this circle and its two sides are reaching all the way to here on this edge of the circle, then it means that this arc will always be 2 times that angle A. For example, if A is 40 degrees in this picture, then we know that this will be 80 degrees of the whole circle. Now in this circle, when you have angle A, this arc will always be A. The thing is, it has to be in the very middle of the circle. Last but not least, the bisecting chord theorem. This is probably one of the most important theorems in all of trigonometry. It states that when you have a chord, which looks like this, it's basically just a cut that touches 2 sides of the circle that never goes through the middle of the circle. The theorem states that when you have 2 chords intersecting each other, this green times this black is equal to blue times red, as stated here. Okay, that is the end of the trig course. Thank you so much for watching.